In the previous video, we looked at the sine and cosine identities for periodicity, where basically we took our angle theta and we added pi over 2 to it to find these identities right here. And the general strategy was that we started with a ray in this first quadrant, this orange line here, and we looked at its x and y values on the unit circle. And we know that on the unit circle, x is the cosine of the angle and y is the sine of the angle. So we have our vertical and horizontal components of this right triangle here. And by adding pi over 2 radians to the angle, or 90 degrees, we basically rotate this triangle 90 degrees so that we get this triangle here. And this new triangle will be at a point on the unit circle where the angle now is this theta plus pi over 2 radians. And knowing the x and y coordinates, we can compare those to this component here and this component here, which originally came from this triangle. And by shifting this triangle, now this horizontal component is the sine of theta, and this vertical component is the cosine of theta. But when relating these to the x and y coordinates of our new point on the unit circle, we need to realize that for the x coordinate, it is now in the negative direction, though the y coordinate is still positive. So we can say that the cosine of this new angle, theta plus pi over 2, would be the negative of sine of theta. And the y-coordinate of this point, the sine of theta plus pi over 2, that would be this vertical component here, which is the cosine of theta. And we can see this relationship right here. And another way to look at that is essentially when you add pi over 2 to the sine function, it shifts the graph of this function, which we'll look at in a later video, so that it becomes the cosine function. And likewise, when you shift the cosine function by pi over 2, it becomes the opposite of the graph of the sine function. And for this video, I'd like to look at the periodicity identity for the tangent function. And to do that, we just need to remember that the tangent of theta is equal to the sine of theta divided by the cosine of theta. Remember that tangent of theta on the coordinate plane is defined as the y coordinate divided by the x coordinate, where y is sine of theta and x is cosine of theta. Now, when we add pi over 2 to this angle, then this would be equal to the sine of theta plus pi over 2 divided by the cosine of theta plus pi over 2. And we can use these identities that we derived, where the sine of theta plus pi over 2, that's just the cosine of theta. And the cosine of theta plus pi over 2 is just the opposite of the sine of theta. And this ratio of the cosine divided by the sine, notice that it's the reciprocal of the tangent. And we define the cotangent function, the cotangent of the angle, as the reciprocal of the tangent function, meaning that the cotangent is the cosine divided by the sine of the angle. So when we add pi over 2 to the angle and put it into the tangent function, we get back the opposite of the cotangent function. Or in other words, when we take the graph of the tangent function and shift it left by pi over 2 radians, then that would be equal to the cotangent function, but reflected over the x-axis, or the opposite of the cotangent function.